synthetic division is the goal for today. You're probably thinking, well, we did long division yesterday. What the heck is synthetic division? Why is it called synthetic division? It's not actual division, it's artificial division. Maybe. I don't really know why they call it synthetic division, honestly, but you'll see what it is. So yesterday we were doing this, long division. And it kind of sucked. I mean, it's not terrible, but it's a little monotonous, right? There's a lot going on. It's a long process. Yep. So there is, in fact, an easier way. There is an easier way. I'm going to show it to you today. It's called synthetic division. And when you see it, you're going to be like, Mr. Smith, you're the worst. How come you didn't show us that the first time? Yeah, it's way easier. Yes. Synthetic sounds kind of scary, but it's not. It's the easier way. Synthetic division is the easier way. And the reason I don't show it to you first is so you don't, if I showed you synthetic first and then I tried to get you to do this, that's not happening, right? That's not going to happen. What? Because there's sometimes that synthetic division doesn't work. And we have to do long division. But usually synthetic division will work. So let me just show you how it works, okay? So I got 3x cubed minus 4x squared plus 2x minus 1, and I'm dividing it by x plus 1. Well, we're going to use synthetic division to do this instead of long division. So it's kind of a goofy setup, but once you get the setup, it's a pretty easy process to get through this, okay? So here's how we're going to start. I'm going to look at the thing that I'm dividing by. And I'm going to take the zero, or the solution, that is associated with that thing. And what I mean by that is, like, if I set that equal to 0 and solved it, what would I get? -1. It's pretty easy, right? Or in other words, all I need to do is I need to flip that thing. But what I'm really taking is the 0 associated with it, okay? So mathematically, that's what I'm doing, but technically, I'm just flipping the number, so I'm going to start by writing -1. Okay? And then I'm going to put in this weird, like, upside down division sign thingy, and that is going to help me stay organized here. This is going to help me stay organized with all my pieces. All right, here's what I'm going to do next. I'm going to look at the thing I'm dividing, and I'm going to take the coefficients of each term. Well, the setup is kind of goofy, but just wait. Just wait. You got to build up the suspense, Just wait. I'm going to take the coefficients, not the variables, but the coefficients. So just the numbers that are in front. So I got 3. Okay. I got -4. I got 2. And I got -1. You okay with where I'm getting all those numbers? Okay. All right, so this is the entirety of the setup. Now it's time to start running through this process. And let me show you what it is. You might think it's kind of weird at first. I promise it's going to be easier than long division. Here's what we're going to do. We're going to drop the first number down. It drops down, okay? And then we're going to do this repeated process of multiplying something and then adding something, and then multiplying something and then adding something. We're just going to do that until we don't have anything left. So yep. Well, they'll come back later. Don't worry. They'll come back later. I'm going to multiply this by this, okay? So multiply. -1 times 3 is -3. I'm going to put that number up here. So I multiply those. And then I add these numbers, top and bottom. So I multiplied. Now I add. What's -4 plus -3? Okay? So I multiplied, and I added. Repeat. Multiply this by this. 7. Add 2 plus 7 is 9. Multiply negative 9. Add negative 1 and negative 9 is negative 10. And now there's nothing left, right? I don't have any more room. So I'm done. So I multiplied this by this. I multiplied negative 1 by 3. And it goes right up here. Yeah. Fills in the next spot. So then I added those numbers. I got negative 7. And then I just repeated that. So I did negative 1 times negative 7. That got me positive 7. I added those. I got 9. I did negative 1 times 9. I got negative 9. I added those, and I got negative 10. So it's just multiply, add, multiply, add, multiply, add, until we run out of stuff. Okay? You guys all right with where all those numbers came from? Feel good about it? Ish? It's a little wonky. Well, guess what? We're done. There's literally nothing else to do. Let me show you. I know you're thinking like, oh, it's just a bunch of numbers, Mr. Smith. Well, here's what it is, guys. These numbers down here are going to be the coefficients of the quotient, which in non-math terms means these are the numbers that are in front of all the variables in my answer. Okay, so just bear with me for a minute. I started with a degree 3. It was a third degree. I just divided something out of it, right? So I divided. It's going to get a little bit smaller. So what degree do you think my answer is going to be? It's going to be a second degree. It's got to get bumped down 1. So the degree always gets bumped down. The degree always gets bumped down 1 because we're just dividing one x out of it. Okay, so here's what the quotient is going to be. I started with a degree 3. This thing's got to be degree 2 now. These are the coefficients. So I just fill it in. It's going to be 3x squared minus 7x plus 9. There's no x on that one, right? Because I'm out of variables now. So then what does that mean this is? This is the remainder. That's the remainder. So then I would write it out the same way we did yesterday. It'll be plus negative 10 over x plus 1. And that's it. That's it. That's all it is. All done. Not a lot, right? And it's just multiplying and adding. You guys can multiply and add stuff. I think you can. I think you can.
I have more problems with like basic math than big theory.
How about we do one more together and then you'll try one? Sound good? Yeah. So the numbers down at the bottom that I get are the coefficients. 3, 7, 3, negative 7, 9. Those are the coefficients of the answer. Okay, yeah. Yeah, if you're missing something, you still need a placeholder. We just didn't have one in this case. Yep, let's do one more together, and then you guys will do one. So let's look at this one. Actually, let's do one with a placeholder. Yeah, let's do this one. So I want to divide x cubed plus 4x squared minus 6 by x plus 1. So remember, I start with that, right? Do you remember what I did with it? I had to flip it. I want the 0 that's associated with that, so I got to flip it. Negative 1. So all I did was flip that number. Negative 1. I put in my weird upside down division sign. Keep me organized. And then I take the coefficients. So what's the coefficient of this one? 1. What's the coefficient of the next one? 4. Okay, then what? Whoa, wait. I see -6. Add in what? Ah, you guys are, make me so proud. I'm missing X, right? We're missing a place. I go cubed, squared, and then I skip X. So I need to add in a placeholder for that. So it's 0x and then -6. Okay, so I got all my pieces. I'm all locked and loaded. We're ready to pull the trigger here and do this thing. So if you remember how we started, we dropped the first number. Okay, the first number came down. That's a 1. And then we just get rolling with this multiply, add, multiply, add, multiply, add. So -1 times 1 is -1. Put that number up there. So then what am I adding? Okay, so 4 plus -1 is 3. Multiply, -1 times 3 is -3. Add 0 and -3 is another -3. What? Yeah, multiply and it turns into a positive. Add and it's another -3. Multiply, add, multiply, add, multiply, add until you're done. Okay, so these numbers, these are the coefficients of the answer. Those are the coefficients of the quotient. So I can write it out. What degree is the answer going to be? Second degree, because I started at a third degree, so I need to get bumped down 1 because I'm dividing, right? That makes it smaller. So it gets bumped down 1, so it's going to be a second degree. So it's 1x squared, so it's just x squared, plus 3x minus 3, and then -3 is the remainder. So it's plus -3 over x plus 1, the thing we were dividing by. And we're done. Is that easier than long division? Yes, it is. Okay, you want to try one on your own? All right, then try this one on your own. So it says determine whether x minus 3 is a factor of the given polynomial. What the heck does that mean? Well, let me ask you this. What if let's talk about a number. Give me a number. 14. 14. What are factors of 14? Okay, 7. 7 is a factor of 14. How do you know that 7 is a factor of 14?
Well, because it divides by 2.
Because it divides it, right? It divides it evenly. It divides it without a remainder. Yes? So how can you tell if this is a factor of this? Yeah, if you divide it and it doesn't have a remainder, then it is a factor. Does it make sense? So try it real quick. Try to get it set up. Try to divide it. See if you get a remainder or not. And I'm going to do it up here while you're working on it too, okay?
So we just do the normal thing.
Just the normal thing, you're just dividing it. So we got to take this. We got to flip it, right? We're just doing everything like we were. So you try to do it on your own. Try to get through it on your own. I'm going to be doing it up here too. So you can check it along with me as you go. Taking the coefficients, 1, -1, -14, 24. Multiply 3 times 1, I get 3. -1 plus 3 is 2. 3 times 2 is 6. -14 plus 6 is -8. 3 times -8 is -24, and that gets 0. All right, so I'm done with the division up here. If you're done with it, you can check yourself with me. So the remainder is 0. What does that mean? It means it's a factor, okay? So really, if it tells you to determine whether it's a factor, you're really looking for no remainders. If you divide it and you get no remainder, then it is a factor. So since I don't have a remainder, I can say yes, it is a factor because it divides it evenly without a remainder. Is this making a little bit of sense? So if you divided it and you did get a remainder, then it's not a factor because it didn't divide it evenly. Doesn't work. Okay? So there's that. And let me show you one more thing here, okay? Just one more thing, and then I'll be done. I'll be done talking at you. We got to talk about this wacky thing called the remainder theorem. The remainder theorem. It's kind of goofy. There's a lot of words up there. It says, if f of x is divided by x minus k, then the remainder is equal to the value of f of k. And you're like, what the heck does that mean? Don't know. English, please. Well, here's an example of it, okay? It says, if you divided f of x, meaning just some polynomial, if you divided some polynomial by x plus 4, and you got a remainder of 102, the remainder theorem says that if you plugged in the flipped number, like the 0, right? If you plugged that in to the thing you just divided, you would get 102. That's all the remainder theorem says. So if you divide and you get a remainder, that means that if you plugged in the 0 associated with the factor that you just divided by, you would get the remainder. Okay, I know it's kind of goofy. It's kind of hard to follow. So let's just do an example. It says use synthetic division to find out what the value of f4. Were you guys trying to write that down? Okay, I'll hang out right there for a second if you're writing it down. And then we'll do this example. All right, so it says use synthetic division to find out what the value of f of 4 equals. F is this thing, x cubed minus 13x plus 12. So guys, here's all you need to do. If you have a problem that is set up like this, all you need to do is look at the number that it gives you, because it gives you the 0, right? And it's not giving you the factor anymore. Like it didn't give you x minus 4 or anything like that. It just gave you the number. So just divide by that number. Divide it all by that number. You don't need to flip it. It gave you the number already. It flipped it for you. So just divide by that number. And whatever the remainder is, that's what f of 4 is. So let's do this real quick. I'm going to divide it by 4. Get my setup. Am I missing any pieces?
Yeah.
What am I missing? X squared. So I get 1x cubed. 0x squared. Minus 13x. Plus 12. I got my number. It's 4. So let's do this. Drop the first number. 4 times 1 is 4. Add. 0 plus 4 is 4. Guys feel like you're getting a sense of the process here? Multiply, add, multiply, add, multiply, add. 4 times 4 is 16. Add, negative 13 plus 16 is 3. Multiply, 4 times 3 is 12. Add, 12 plus 12 is 24. All right, so 24 is the remainder. So by the remainder theorem, since I divided it all by 4, I can say that if I took 4 and plugged it into this thing for x, I would get this. All right, so I can say that f of 4 is 24. And that's all the remainder theorem is getting at. Okay. The remainder theorem's not like monumentally important for us. It will come up again a little later though, so I just want to show it to you. All right, questions on that at all?